Alright, how to find angle between resultants and each of the forces. In some questions, they'll tell you find the acute angle between them. However, they ask you, this thing here is an acute angle because it's less than 90. Notice it is less than 90. So if they ask you acute angle between them, notice that this triangle here, this thing that is a triangle that looks like a triangle here, more like this way, something this way, that you're seeing here, where you have the arrow and you have this. So this is the angle between them. That is, or they say acute angle. This is how to find the angle. That is the resultant, the angle between them. The angle between them. So the angle between them, that means up here as well. This angle and this angle, the angle between them, between the resultant. So when you know this, it simply means that anytime they angle between them, not angle between the two forces, but angle between the resultant and each of the forces, or they tell you find the angle between the acute angle between the resultant and each forces. This is how you find it. So notice that when you have this way now, this one that is this way, you have something like this, which I've drafted out. So I'm using this as an illustration. So I've drafted it out here. Notice that this forms a right angle triangle. If you look at it very well, it forms something like a right angle triangle. So that I now have my F1 is the same as the F1 given to me and the F2 given to me this way. So this is parallel to this. So AC is equals to BD. So if I know that, now I have that to find y is always the part vertical and x the part horizontal. To find y is the same thing as saying this angle is facing y opposite. So anything so is sine theta equals to this. So y will be F1, that is opposite y over hypotenuse F1. So when you do the mathematics, you see that y is equals to F1 sine theta. Now for x, the part horizontal to this is adjacent over hypotenuse k, that is cos theta. So cos theta is equals to x over f1, x over f1. So if you do the maths very well, you see that x is equals to f1 cos theta. So that means that for this part now, that means that on this triangle, everything horizontal here, it means that everything horizontal components for this particular parallelogram, horizontal components is equals to f2, that is f2 plus f1 cos theta. Reason being that if this is the same thing as equal to CD plus DO, and DO is equals to this, YCD is equals to this. Now for vertical components on this parallelogram, this thing is very important. It's different from when they ask you angle between each of the forces. Angle between each of the forces is this way, and it's something this way. Now angle between this resultant and this force is this thing I've drawn here, this way. The angle between this particular one for F2 and the angle between this one for F1 is this way. So if you know this, for vertical components of this parallelogram, this one now that I'm looking at is going to be equals to everything vertical here. Notice it, everything vertical here is the same thing as this way, and this way. So everything vertical that happened on this is the same thing as, notice it, is the same thing as saying BD. Look at it, AC, and AC is equals to BD. So it's the same thing as BD plus BO. BD plus BO. So AC, if AC is equals to BD, that means that on this part where I have BD is having these parts, which is the same thing as saying BD. Since BD is equals to AC, BD can represent it, BD plus BO. And what is BD? First of all, look at this. BD is F1 plus okay, this side now is Y, And if this is y, notice something. If this is y, notice that this is the sentence saying f1 y. This is the sentence f1 plus y is equals to, remember that we got y here, and y is equals to f1 sine theta. f1 sine theta. This is it. But notice that tan theta is always equals to y over x. If you still remember trigonometry, tan theta is always equals to y over x. If you remember. So what is our y here? Our y is equals to this. Now, what is our x? Our x is equals to everything on the horizontal components. Everything on the horizontal components. Everything on the, because the horizontal component, everything on the horizontal component is through this way. Horizontal component equals to x. Horizontal component equals to x. And everything on this, now, there is no angle on this horizontal component. Notice that this one is at an angle. But everything here is totally horizontal. So that means that this is now going to be, let's take the value of y here. This is going to be the sentence as f1 sine theta all over our x. Everything for our x is everything down there. So it's the sentence as horizontal CD plus DO, which is equals to f1 sine theta all over CD has f2 there plus DO has x there, which is, I could have used any value for this, so which is f1 cos theta. So anytime you are asked to find the angle between the resultants and each of the forces, or they tell you find the acute angle between them, this is the formula to use. But when they tell you find the angle between the two forces, that's when you use r squared, that is cosine rule, equals to f1 square plus f2 square plus 2f1 f2 cos theta. So there you have it. We've been able to treat addition of vectors, subtraction, parallelogram, triangular row. Then in our next class we'll treat relative velocity, then we'll start solving questions.